right, let's get right into it. We're going to talk about a technology that didn't just change the game for data centers, it completely flipped the table over. A shift so big, it honestly felt like some kind of magic. And, like all good stories, this one starts with a single moment. I'll never forget the day the reality of hyperconvergence really hit me. You know, picture this. You're in the middle of a massive data center migration. On one side of the room, you've got the old stuff, just towering racks of servers and storage arrays. And on the other side, well, something that seemed impossibly small.
The old equipment, the legacy gear, it took up 84 rack units. To put that in perspective, that is 2 full-sized cabinets completely jam-packed with blinking lights, whirring fans, and a spaghetti monster of cables. I mean, it was a massive physical footprint.
And the replacement for all of that? Just 6 units. The difference was, well, it was violent. And this right here, this is the whole story. We went from an era that was all about expensive, specialized hardware to an era that is all about incredibly smart software. The physical storage array didn't just get smaller, it was basically absorbed, you know? It got virtualized and just turned into code.
So you have to be asking, right? How on earth is a transformation that radical even possible? It feels like it breaks the laws of physics. Where did all that hardware go? To get the answer, we've got to go back in time, back to the source, to a problem that seemed absolutely impossible to solve.
See, the magic of hyperconvergence, it wasn't dreamed up in a typical corporate data center. Nope, it was forged in the fire, in the labs of the web giants, companies that were facing a problem of scale that nobody had ever even seen before.
So, back in the early 2000s, Google had a simple goal: index the entire internet. But the traditional way to do that, buying these super expensive, super reliable storage systems, it just wouldn't work. The cost would have been astronomical. They hit a wall, a dead end. So they did something radical. They changed the rules of the game. And they laid out this whole new philosophy in a now famous paper about something called the Google File System. And this right here, this is the philosophical leap that changes everything. Instead of spending a fortune on premium hardware that was designed never to fail, they just embraced the chaos. They decided to use cheap, off-the-shelf commodity servers, and they accepted a simple, radical truth. Hardware will fail. It's not a possibility, it's a certainty. The genius was to stop fighting that reality with expensive hardware and start expecting it and managing it with brilliant software. Okay, so that's the big idea. But how do you actually turn that philosophy into a system that works? Well, it all starts by totally redesigning the basic building block of the data center, the server, which in this new world we call a node. And the secret ingredient, the magic behind the curtain, is something called the controller VM, or CVM for short. Just think of it as the brain of the whole system. It's a special virtual machine, and it runs on every single server in the cluster. And its one and only job is to grab all the individual hard drives and SSDs from all the different servers and magically weave them all together into one giant, shared, intelligent pool of storage. This piece of software literally replaces that old, clunky physical storage box.
Now, here's where it gets really, really clever. How does this CVM get such amazing performance? It uses a neat little trick called PCI pass-through. Now, what that means is it basically gives the CVM a VIP backstage pass to talk directly to the physical disks. It gets to completely bypass the hypervisor. That's the normal traffic cop for virtual machines. The result? You get raw, unfiltered performance with none of the usual overhead. And this direct access, this VIP pass to the hardware, is what enables some truly incredible new abilities. This whole architecture doesn't just work. It unlocks things that were just plain impossible before. So let's look at what we'll call the 3 superpowers of hyperconverged infrastructure, or HCI.
Superpower number 1 is called scale out. And the absolute best way to think about it is like building with Legos. The old way of growing was called scale up, which meant when you ran out of space, you had to buy a bigger, badder, more expensive box. It was a nightmare.
HCI just flips that whole model on its head. You need more resources? No problem. You just add another node, another server, another Lego block. The cluster's software brain instantly sees the new resources, the new CPU, the new RAM, the new storage, and just absorbs it into the pool. Growth becomes totally linear, predictable, and best of all, painless. Those horrible 5-year capacity planning meetings? Yeah, those are a thing of the past.
All right, superpower number 2 is data locality. And for performance, this is the holy grail. See, in the old world, your application running on a server was always yelling across a slow network to get its data from a separate storage box. It's a huge bottleneck. The HCI software is smart enough to make sure the data lives on the exact same physical server where the application that needs it is running. The path from the brain to the data becomes practically instantaneous.
And finally, we have the third superpower. And I'm telling you, this is the one that makes every system administrator who's ever lived through the terror of a disk failure a true believer. It's called distributed rebuild. And this comparison says it all. In the old days, a disk dies, and a single hot spare disk has to work its tail off, sometimes for days, to rebuild all that lost data. And the whole time, your system performance just crawls. It's a nightmare. In the HCI world, one disk fails, and guess what? Every single other disk in the entire cluster jumps in to help rebuild the data. It turns a days-long crisis into a minutes-long inconvenience. It's a total game changer.
Okay, so this all sounds incredible, right? Maybe a little too good to be true. And you know what? It's important to be realistic. This isn't actual magic. It's a series of really smart engineering trade-offs. And you have to understand the costs that come along with all this beautiful simplicity.
The first cost is something the industry calls the CVM tax. Remember that software brain, the controller VM? Well, it needs resources to do its job. It eats up some of the server's CPU and a pretty big chunk of its RAM. We're talking 20 to 24 gigabytes on every single server. And that's horsepower that your actual applications can't use. It's simply the price you pay for all that software intelligence.
The second trade-off is a biggie. It's a huge dependency on your network. Since data is constantly being copied and moved between all the nodes for protection and performance, the network becomes the absolute central nervous system of the whole cluster. Let me be clear. If your network has a problem, your HCI cluster has a problem. You have to get the network right. There's no way around it.
So we have this brilliant, world-changing idea born inside Google's labs, but, an idea is pretty useless if it just stays inside a lab or a research paper. Somebody had to take these incredibly complex web-scale concepts and package them up, make them simple enough for any company out there to actually use. And that company was Nutanix. It was actually founded by former Google engineers, folks who had worked on the very systems that inspired this whole revolution. They set out to bottle that lightning, to package all that power into a product anyone could buy. They essentially took the blueprint from the Google file system and built a commercial version for the rest of us. And that's really the story of how hyperconvergence shrank the data center by turning physical hardware into intelligent software. But it does leave us with one last really fascinating question, doesn't it? How exactly did one company manage to tame this incredibly complex, web-scale beast and make it simple enough to start a revolution? Well, that's a story for another time.